constraints. Today our session start with the constraints. What is the purpose of constraints? The main objective of constraint is to improve data quality. The main objective of constraint is to improve data quality and accuracy. Data quality and accuracy. Or accuracy. Accuracy nothing, quality nothing but accuracy. Or quality or accuracy. That's it. So these are classified into different types of improve data quality or accuracy to loading the data into tables. So where it is accuracy? Wherever you loading the data, wherever loading the data into tables. Data into different types. They have different types of table, dimension table and fact table. You'll see that different types of tables later. Anyhow, if you want to load the data into different types of tables for data accuracy and or quality purpose, we are using the constraints. That's the main object. Let's say these are classified into different types of constraints. These are classified into different types of next constraint. Different types of constraint. First one is unique constraint. Unique constraint. Second one is not null. Third one is check. Fourth one is primary. Fifth one is foreign. Sixth one is reference. So unique, not null, check, primary, foreign, and reference. These are the 6 types of constraints. Okay. So unique constraint. What is the purpose of unique constraint? Unique constraint, not null. Unique constraint is it does not allow the duplicate values. Unique constraint, it does not allow duplicate values. It does not allow duplicate values. Not null. It does not allow missing data. Missing. Check. Read the data conditional. Read the data conditional. Read the data conditional and load into tables. Primary key. It does not allow duplicate values and duplicate observations and missing data. It does not allow missing data, duplicate observations and values. Simply, we can say that the similar nature of the combination of unique and not unique and not. So coming to foreign key, reference key. So these are coming to primary key, primary, foreign, and reference. Reference keys are helps to load the data. Helping to load the data. Helping load the data into fact tables. Depending upon the dimensional table. So primary key, foreign key, reference keys are helping to load the data into fact tables depending upon the dimensional table. Now coming to, we had two types of tables. One is fact table, second one is a dimensional table. What is the difference between fact table and the dimensional table? Okay, simple. Fact table, nothing but it has measures. Fact table, it consists of measures. Measures nothing but using unique, not null, check, those kind of constraints. With the help of those constraints, we can load the data into fact table with the help of dimension. You can load the data conditions, whatever that conditions, okay, constraints are available is there, that is called fact. Okay, just like measurements, it has all measurements. It consists of measures. And just like dimensional table, dimensional table nothing but just like a raw data set. Okay. So in raw data set we have like missing data, duplicate records, right? Missing data, duplicate records, and duplicate observations are available. So that is called dimensional table. Just like a similar nature of raw data. That is it. Without duplicates, without missing, that is comes under fact table. With duplicates, missing data, duplicate records, nothing but a dimensional table. That's it. Very simple. With the help of dimensional table, with the help of relations, like these are primary, foreign, reference, it establishes the relation between the dimension table and the fact table. Okay. It establishes the relation between the two tables using key variables. That's why, so primary, foreign, reference keys are helping to load the data into the fact tables using, depending upon the dimensional table. You can load the data with the help of these all the constraints. If not, check primary, foreign, reference keys. Okay. We'll see. These are the 6 types of constraints. Let's say see here. So integrity names. Next, integrity names. Integrity names of the constraints. What is the meaning of integrity name? Integrity name is nothing but alias name or alternate name or addressing of the constraint. Integrity names of the constraint, nothing but is another name or alias name or addressing of the constraint. It is alternate name of constraint. And we can assign that integrity names 2 ways. So we can addressing the constraint with their integrity names. We cannot directly, sometimes we don't directly call that constraint names. Sometimes we can call with without constraint, and it means constraint name and without constraint sometimes. So here it is alternate of constraint, alternate name of constraint, and integrity names are two types: constraint, and these are two types. Alternate names are two types. One is system defined integrate name. These are two types. First one is system defined integrity name. Second one is user defined integrity. System defined integrity name nothing but created by the system automatic. System defined integrity name created by the system. These are created by the SAS system. How do we identify these kind of constraints? We would identify with the constraints, system defined constraints, or start with underscore, end with underscore. These are created by the SAS system and start with the underscore, end with underscore, end with the underscore, start with underscore, end with the underscore. Start with underscore, end with the underscore. And limited to constraint, it means integrity name limited to use up to 8 characters. We can use up to 8 characters. Come on. Integrity name, can be used up to 8 characters. Example for that system defined integrity name. Let's say underscore UN XX. Okay. X underscore. It is limited up to 8 characters. Next, that is identify with the similar nature of unique integrity name. You can call addressing of the constraint. Next, not null underscore nm underscore check underscore ckm primary key underscore pk underscore foreign key fk underscore reference key underscore, just we can use ref, that's it, reference key. Generally it is established the relation, that's reference. So these are the alternate names of the constraints, the system defined integrity names. Let's say coming to user defined constraint, these are created by the user. These are created by the user used up to 8 characters. Example for that user defined integrity names: en1 unique, nt1 ck1 pk1. That is up to. We can use numbers also. We don't do numbers at the starting of the integrity name. We can use middle or end of the integrity. That's it. Okay. fk1 or fk2, whatever it is. Rf sentence. Okay. So this is only relation. Establish the relation. That's it. Reference. So these are the different types of integrated name. System defined integrated name and user defined integrated name. Okay. That's it. Next, integrated names. It means constraints. Constraints can be assigned in two ways. First type is column wise, and second one is group wise. It means table wise. So constraints, note point. Constraints are assigned in two ways. First type is column wise, and second one is table wise. Column wise nothing but like variable wise, variable name wise. We can assign the constraint, variable name wise, variable name. Here table wise nothing. We can assign the constraint group of the variables. We can assign the constraint group of variables. Here we can use only single variable. Single. Here this is multiple variables. You can assign the constraint for group of variables. Constraint for group of variables. If only single variable, we can assign group of variable. We can assign using table wise. Okay. And not only two ways, we can assign that constraints with a different applications. Different applications or different statements. Assign the constraints with the different statements. Assign the constraint with the different statements. First one is assign the constraint without constraint name. Assign the constraint. Assign the constraint without constraint statement. Second one is assign the constraint with the constraint statement. Third one is assign the constraint using alter statement. Assign the constraint using alter statement. So using, we can assign the constraints with the different statements. Okay, without constraint statement, with constraint statement, using alter statement. That's it. Okay. Next, we want to assign the constraints. We have to follow the data warehouse concept. Data warehouse concept. So data warehouse is one of the internal component in SAS. Is one of the software or component in the SAS. Okay. You have to follow that data warehouse concept. You have to know that data warehouse. And what is the meaning by data warehouse concept here? Where we can store the data in meaningful, understandable format is called data warehouse concept. Or where we can maintain the data with accurate. That is called data warehouse concept. Okay. So where we can maintain that, where we can maintain the data in meaningful, understandable form. Understandable form. It's called data warehouse concept. It follows again, data warehouse concept follows 3 types of steps. First one is first step is data designing or data modeling. Data designing or data modeling. Second one is ETL. Third one is control, quality control. Quality. You have to follow the 3 steps. Data designing means nothing but creating a null table. And we have to follow that. After that, we have to follow that. Next step is ETL. ETL stands for extraction, transformation, and loading. Terminology is different, but we know that what is extraction. Extraction, nothing but importing. Transformation, nothing but depend upon the requirements. You can modify the data. Just rename the data, assign the labels, or control the length of the variables. That is a transformation. Loading, nothing but load into fact table using dimension table, using proc append procedure. Terminology is different. Procedure is well-known procedures. We know that it is not new for you. You know that, but terminology is different. That's it. Quality controlling is just loading the data. These 2 process is how we can control the data. Quality controlling. It's not a separate step. We're controlling the data. We load the data into table side. That is called quality control. How the data is controlled, whether it is duplicate values, you can checking that. The data after completion of a task, we check that output results, whether it is correct or not, whether it is duplicate values, whether it is load the data according to that our customization or not. You can check out all those things. That is called quality control. We'll see now. Data control, just data designing, nothing but data designing a data model means nothing but data modeling. We will create null tables with the constraints. Create null tables with the constraints. Second, ETL. ETL stands for extraction, transformation, and load. And so extraction, nothing but import the data. Importing, like edit the data, depending upon the requirement, you can load the data using proc and process. That's it. Very simple. See here. Very simple. We are importing different types of files, right? Either a CSV file, Excel file, whatever the file. Okay. Extraction, and after transformation, after creating, you can load the data into different files. That's it. How we can extract using proc import procedure, right? What kind of files? Excel files, text files, any Excel files. Okay, access files, app files, CSV files, whatever it is, you can import it. So this is called extraction. This process called as extract. After that, we have to transform the data. Transform, like edit the data. It's named like modify the data. Modify the data, just like a transformation. That is called transformation. Transformation. Next, after completion of task, we have to load the data into PC file. Like loading is called loading. Loading into PC file, PC or server, anyway. That is standardized. Standardized purpose, understanding purpose. Okay, you have to load the data. Extraction, transformation, and load. Next, quality control. Just check that the data. That's it. Let's try with one example. Try with one example. How to first create a data model for the data modeling and data design, and assign the constraints. Without constraint, we will see that without constraint name and with constraint name, we have to assign that constraints with statements with the constraint name, without constraint name. It means without constraint name, nothing but system defined integrity names. Backend system defined integrity names are working. With the constraint name, nothing but that is user defined constraint. That is the we'll see. Let's first start with create a null table with constraint. That is called data model or data design. Before that, better to create one library. All constraints I want to load into one single library. Okay, better to take. Otherwise, you can take other libraries also, but you can take any before that assign the constraint, because they have to establish that relation between that table set. Better to in a single library, it communicate better between the two data set in a single library. That's why create a library. Before that data modeling, create a library and storing constraint in that particular library. Let's say create library. Libname, right? Libname. Create libname, that is cd c file path, assign the file. Let's say copy the file path, paste over. This is our